Hi all. In the last class, I have clearly explained the fragmentation patterns of aldehydes. Today, we are going to discuss the fragmentation of ketones. They give strong molecular ions, and the common fragmentation methods are alpha cleavage and McLafferty rearrangement. And during alpha cleavage, the larger alkyl group is more likely to be expelled as a radical. Okay, so here either R dash, this fragmentation could be at two places. It could be here like this, R dot and R dash CO plus will be obtained. That is the first case, and from there R dash plus can be obtained. Okay, the second cleavage, it could be from this R dash side to give you R dash dot and RCO plus fragment, and that could again fragment to R plus and carbon monoxide. Okay, this is the alpha cleavage. And this is the McLafferty rearrangement. You should remember the requirement. There should be a gamma hydrogen, and this gamma hydrogen abstraction is followed by alpha beta cleavage. And so this is alpha, beta and gamma carbon atoms, and obviously this is gamma hydrogen. So that is expelled by this oxygen atom, that is abstracted by this oxygen atom, and therefore as a result this bond comes down, this goes up, this will go up, and this will come down. So you are getting a species like this plus an alkene. I have taken the example of 2-hexanone to explain both these, alpha cleavage and McLafferty rearrangement. Okay, so the first fragment, the first one to be recorded, the first peak to be recorded is the molecular ion peak, which is at 100, m by z is equal to 100. From there, this base peak is obtained at m by z is equal to 43, which is due to CH3CO plus fragment. Okay, so to get that fragment, the fragmentation would have occurred here to give you C4H9 dot and the remaining plus CH3CO plus. Okay, and in the second fragmentation, that one would have occurred here to give CH3 dot and the resulting plus. The m by z is at 85. Okay, and then McLafferty peak is at m by z equal to 58, and propane is the byproduct for McLafferty rearrangement. Okay, then the point to be noted is that the base peak of almost all methyl ketones is at m by z is equal to 43. Okay, 2-hexanone is a methyl ketone, so the base peak of almost all methyl ketones will be at 43. When it comes to cyclic ketones, the fragmentation is rather interesting and it may lead to a variety of products. Okay, so the first one occurred. In the first step, the fragmentation occurs like this to give you a dot here. Okay, to give you a dot on this carbon atom and another dot on this carbon atom, and this dot combined with the dot of oxygen which was already existed to give you the third bond, the triple bond. Okay, and this is the first segment which is at m by z is equal to 98. Still m by z is equal to 98 because there is no change, nothing has gone out. And now here, from here to here, what happened? This bond breaks. Before that, okay, I'll just tell you the first one. This bond breaks to give you H dot and dot at this carbon atom. Okay, and this H dot will combine with this CH2 dot to give CH3. Okay, and from here, see this carbonyl carbon, this is, let us number first carbon, second, third, fourth, fifth and sixth. Okay, you can see that first carbon is this one. Okay, and this could be the second carbon, third one, fourth one, right? Okay, now from here to here, what might have happened? Okay, for this to close, one, second, third, fourth, and fifth. Yeah, here fragmentation would have taken place like this to expel CH3 dot. CH3 dot is expelled, and the resultant one is this one. Okay, there are 5 carbon atoms. The 6th methyl group is expelled. Okay, hope it is clear. And the MYZ value is at 83. And now see from here, suppose this doesn't take place, and another possibility is to eliminate an acetylene molecule like this. See here, then here there will be a dot, and this is CH, right? CH. Okay, not acetylene, ethylene molecule. This was CH2 and this is also CH2. So CH2 double bond CH2, there will be a double bond. Okay, so this CH2 double bond CH2, this much is expelled. Okay, C2H4 is expelled. It's not C2H2. Sorry for the mistake. And now you will get a fragment like this. Dot and plus will be there, but on different positions. So the MYZ value is at 70. And from here to here, what might have happened? The CO is there, second and third carbon, only these much are there, right? So the fragmentation occurred. Let me use another color. Okay, the fragmentation occurred here, so that there is an electron on the second and third positions, odd electrons on second and third positions, so that they can pair up easily to give you a double bond here. And the MYZ value of this one is at 55. Okay, these are the main fragmentation patterns of cyclic ketones. I have taken the example of the most important cyclic ketone or the most common cyclic ketone, which is cyclohexanone. And the last one in this discussion is that of aromatic ketones. I have taken the example of the most common one, which is acetophenone. Let's check. Okay, here only alpha cleavage. I have discussed only the alpha cleavage, because that is the only prominent one. And here alpha cleavage, it could be CH3 dot is expelled, and the resultant is benzene ring CO plus, which is at MYZ value 105. Okay, and this is the base peak. This is the base peak. MYZ at 105 is the base peak, and see the base peak of all phenyl ketones. It's a phenyl ketone because the one group attached is a benzene ring. So it's a phenyl ketone. For all phenyl ketones, the base peak is at MYZ is equal to 105. Okay, now from here, carbon monoxide is eliminated to give you a phenyl carbocation. And from here, you might be remembering, in the case of aldehydes also we have discussed this one, in the case of phenols also, an acetylene molecule is expelled like this to give you a species like this with MYZ value 51. There, in the previous example, in those examples, the base peak was at 51, but here in the case of ketones, aromatic ketones, the MYZ value is at 105. The base peak is at 105. Please remember that difference. And another possibility of this alpha cleavage is removal of this benzene ring as a radical to give CH3CO plus. Okay, as the positive fragment with MYZ value is equal to 43. Okay, it's all about the fragmentation of ketones. Thanks for listening to me.